Hey guys, how you doing? Today we're gonna go over why the absolute value function is continuous but is not differentiable at x equals 0. First of all, I want you to get the notion of the absolute value function graphically and algebraically. So first of all, we're gonna say that the absolute value of x, that is simply the function, is gonna be a piecewise function. So we're gonna have for x, so basically for x, when x is greater or equal to 0, then we're going to output x basically. And if x is smaller than 0, so x is negative, then we're going to output negative x basically. This is the definition of the absolute value function. If you don't understand it, basically it's a piecewise function, that is that it has different pieces. And one piece, for example, is if you plug in any positive number, you're going to get that same positive number. If you plug in a negative number, you're going to multiply that negative number by -1. So you get that same number, but the positive version of it, basically. Now, how would this function look in a graph? So let me give you a graph. Now, let's say this is going to be our grid. Now, how would the outputs and inputs for this function look like? So for example, if we say that this is going to be 1, we know that function is just going to output 1. So we're going to have something up here. Now, what if we had 2 over here? Well, then this is just going to be 2. If we had 3, this is just going to be 3, basically. So it's a line, basically, that goes like that. And what about the negative numbers? So basically, if we have -1, that's supposed to be -1, wait. We have -1. Well, we know we're going to have the positive version of -1, which is just going to be +1. Now, what if we had, for example, -2? Then we're going to have +2. What about -3? Well, same thing. We're going to have +3. Now, it is going to be the same line, but you see it has a different slope. It has a negative slope, okay? So you would go something like this. So these are the two lines that we get. Now, I want you to think now with the definition of differentiability. Hopefully you remember it. So remember that it's going to be the limit as x approaches any number a from the right side. This is supposed to be an arrow. As x approaches any number a from the right side, for the derivative of f should be equal to the limit as x approaches a from the left side for that same derivative, okay? This is the definition of differentiability. Now, let's try to find the derivative, or to try this definition when x is approaching a and a is equal to 0, okay? So let's see what we would get. So first of all, what is going to be f prime for absolute value function? What we need to do in this case, if we want to differentiate a piecewise function, we're going to differentiate each one of its pieces, or each of its pieces. So basically, for this first piece, we're going to say that f prime of x1, we're going to say this is the first piece, is just going to be the derivative with respect to x for x, okay? And how much is this going to be? This is just going to be 1. And now that makes a lot of sense, because remember, we have a linear function that is just simply mx plus b, m is equal to 1, b is equal to 0. And now remember that you're going to get back the slope for any linear function if you take its derivative, which is basically the slope for this. In this case, we know m is equal to 1, which is the same derivative that we have right there. And now what about this piece? If we say f prime for 2, let's see what we would get. So we would have, again, the derivative with respect to x for -x. And I missed the parentheses up here. For -x. Now, how much is the derivative of this? Well, we know derivative of x times -1, that's just simply going to be 1 times -1, -1 we get. And once again, that makes a lot of sense, because for this piece, which is the left side of the graph, we're going to have a slope of -1. So m is equal to b is going to be equal to -1. Now, why is this important? Well, now with these functions, we can try the derivative, the differentiability definition, not the derivative definition. So let's do it. So let's say when x, for x is equal to 0, let's see if it's differentiable. So we're gonna go the limit as x approaches 0 from the right side. So we would be using this piece right there. because this piece is representing the values that are greater than 0 or that are positive basically. So we're gonna have this function is just gonna be f prime, and f prime we know is gonna be 1. So 1. And now we want to see if this is gonna be the same for the limit as x approaches 0 from the left side. Now from the left side would be this part right there, and we know this part since we have negative inputs is gonna be this piece right there, or f prime sub 2, or yeah, with these two right there. So basically this derivative we know that it's gonna be -1, so we can plug in -1 in there, and now you can just simply see that these two guys where we're gonna have 1 and this is trying to see, and we're gonna have 1 is definitely not the same as -1. Okay, we simply just solve these two limits, and since we do not even have x, we know this is just going to be a straight line, and for any value of x approaching whatever from whatever direction you want, it's just gonna be 1 on this side and -1 on this side, and these two numbers they are not the same, which means that these two limits right there, which is the same as what we have in the definition, they are not the same, so we cannot differentiate the absolute value function at x equals 0. Okay, that is basically what happens. However, this function is differentiable at x is continuous. I'm sorry, this function is continuous at x equals 0. Why? Well, let's try. So we know that if we have the limit as x approaches 0 for the function absolute value of x, it should be the same as the absolute value of 0, and it should also be the same for the limit as x approaches 0. This should be right side, this should be left, for absolute value of x. Okay, now let's see how much we get. So if we approach a very close number from the negative numbers, we know it's going to be that same number, which is very small, but it's positive version. So now what's going to be the limit? Well, that's just going to be 0. So we're going to have 0. Now absolute value of 0, we know it's going to be 0. And what is the limit as we approach a very small number, but that it's positive? It's going to be that same small number, and its positive version of it, which is just going to be 0 once again. Okay? So now this proves that since we're getting the same value for these three expressions, the function is continuous at x equals 0. Absolute value is continuous at x equals 0. But since we got different slopes, basically, the function is not differentiable at x equals 0. Okay? Remember that graphically you could see the differentiability definition like this. So basically if you have something like this and you have a curve and you have 2 points, and we could say A is over here, so this is going to be A, and you have 2 points, they have a tangent line, and they're like this. What would happen if you brought, let me make them bigger, what would happen if you brought these 2 points closer and closer? These two lines, which I'm going to say this is A and this is B, these 2 points, as they get closer and closer, B is eventually going to approach A, okay? Or you could say A is going to approach B, basically. And this is going to result in A is equal to B. The two lines are going to be the same thing because they are approaching that same value of A. And the slopes would be the same. The slopes of that tangent line would be the same. But that is the total opposite that is going on in here. We have that as we approach a point A, which would be 0, the slopes are not going to be the same, because as we approach, if in this line you can already see it, if you approach 0, what is going to be the slope of the line? Well, it's going to be -1 if you approach it from the left side. But if you approach it from the right side, then you're going to have a positive slope, which is going to be 1. Okay, and the two slopes, they're just simply not the same thing. So that means that, well, it's not differentiable, because the slopes, this scenario is never going to happen. The slopes, if they meet, or if those 2 points meet at the same point, they are not going to have the same tangent lines. And therefore, they're not going to have the same slope. And that means that the function is not differentiable. So I hope you understand all of this. I hope you now see why we can say that a function is continuous, but it's not differentiable, okay? It's a pretty interesting idea. So, well, I hope you learned something today, enjoyed this video, and, well, I hope you subscribe, and see you in the following video. See ya!